So within our midst, we have William Kirkwood. It's a pleasure to have you over here. A little bit about William before I call him to the stage. He's currently a senior research and development engineer at the Monterey Aquarium Research Institute, which is in California. He's been there for 25 years, and he's worked on a number of ROVs and developed on a number of ROVs and AUVs. So without further ado, I would like to invite Will to the stage.
What I wanted to do was have a little fun today because we've got some great speakers coming that will talk about multiple vehicle systems. Stephen Williams out of Astoria is really good at that. And so I thought I'd talk about something that's really on our minds, and it's coming to the underwater robotic world, and that's what we call artificial intelligence. Although, I don't know why we call it artificial, because if it's intelligent, it's intelligent. It's not really artificial. So why do we use robots? And I found this slide about the advantages and disadvantages, and I liked it because it was very simple. So when we're bored and we want to do things easier and cheaper, or it's dangerous or something like that, that's an advantage. The thing I liked about this slide, which I thought was quite funny, was there's also the problem of evil people using robots for evil purposes. And that's a real problem. And as you get into AI, we have to worry about what these robots will do on their own. So before I start into that, these are some of the vehicles that we're running today. And you can see there's quite a different series of them. And I'm going to give these slides to the guys as I do every year. There'll be a file that you can pick up and get all those. And so here's a bunch of the vehicles that are going on. This one's still in development, but they're all going good. The surface vehicles, I think a lot of people here are using them in Singapore even. And then here's some of the ones that I'm really interested in, is where we're going, where we're taking multiple vehicles from the air to the surface and to the bottom and making them function together. And Stephen Williams will talk about that, I'm sure. This is one that I'm developing right now, which is taking a long time to get to because of money, but it's a lot of fun. So if we integrate these things in a smart way, and this is something I worked on years ago back in MBARI 2003, and I think it was 2001, 2003, called the Autonomous Ocean Sampling Network. What this did was integrate vehicles of all types to create these kinds of functions, right? And then we had these nested maps. So this is the Monterey Bay here, and these are boundary conditions of models. And what we do now with this data is we use this to predict where we're going to have plumes. So the poisonous plumes, you see red tides and so forth. And then we place instrumentation in robots there out of these predictive models. So this was an early type of thing. It's not AI, but it's very early about what you can do. And we still use it today. So what's changing? This is a slide I've used for many years, but this was from the late 90s, and AUVs were really moving into the remotely operated vehicle market. Nowadays, we're quite a ways into the remotely operated vehicle market. All of our mapping is now done by AUVs at MBARI and I think almost every research institute. I don't think anybody uses ships anymore for multi-beam mapping. The hydrographic survey gliders and so forth, they're moving in, doing side scan work now and so forth. So we're managing power and we're managing missions, and pretty soon, I think a lot of this other stuff, the intervention, is what's coming next. So we're seeing robots. If you want to look up some stuff, the guys at Girona, Spain, they've got an AUV that has an arm, quite a big heavy one, and does a lot of manipulation work using vision. So we're really moving very fast out into these areas and doing surveys. I'm sorry if I'm rushing, but I was promised I'd get you to lunch on time. So now, but people are still nervous about robots being out there all alone and so forth. And so the driving cars, for example, I think most of you are aware of that. So we're working around this problem. This is Rolls-Royce's work, and they've created this ship. They're still working on it right now, but they expect to go into service in 2020. There'll be nobody on the ship at all. The captain will be in a building someplace, running these ships and flying them remotely. So he'll probably fly or command several ships at once. Why not? But there will still be a human in the loop. So this is expected by 2020. And I'm on this committee, also the standards committee. And what that committee is doing is taking the communications between ships, subsea robots, aircraft, cars, trucks, trains, and trying to make it all standardized so that when this cargo ship gets to the dock, another robot can talk to it and take off the cargo. So it's all going to be interconnected. So now, what did early AI provide us, and what did it look like? So you guys, how many of you are programmers in here? Some of you do software, right? Really, that's all? This is usually pretty heavy with software. Okay. I think you guys are familiar with loops and so forth, and this is what the structure looks like for what's called subsumptive architectures. And so, it's doing this really simple model, but what did this do? These are called behaviors, is the way it worked, and this was out of MIT's labs. And what I got out of that, this is what we did on the vehicles I worked on, was if I look at this model here, right, and I say stay above the bottom X meters. So when I'm coming down and I get to some 5 meters, let's say, above the bottom, it stops. Okay? Then I have a behavior that says set the dive depth to Y meters. So I'm telling it go to some depth. Okay, now each of those behaviors by itself is one little block of code that says do some function. And then down here it says don't hit something. And then here, right, it's a safety thing. If it's going to run out of power or it's lost, doesn't have a safety watchdog on the computer, abort. And so these are set up in a hierarchy. So this was the very, very beginnings of AI, at least in my experience with it. So now if you look at what this does, I have X, don't go any closer to the bottom, right, than 5 meters. And I have Y, I'm telling it to dive below the bottom. And then I'm saying don't hit anything. And if you look at the order those things were structured in, right, the bottom has the priority. As it goes up, the priority lessens. I've created a new behavior without any code. So now I have terrain following because I'm telling it to dive constantly to the bottom, but not go any lower, and that has a higher priority. So this was a very, very early AI type work. Now, would you call it AI based on this? Not even close, right? It's some fancy programming. Do you guys do this here at Singapore too? Yeah. So is that how you used to run your vehicles? Yeah. That's where we're all stuck today. So subsumptive architecture is still going on, but very quickly it's going to go away, I think. Are you guys moving on to AI type style? So, yeah. So this is the guy who was considered the father of computers and so forth, a guy named Turing. I guess most people know him for breaking Enigma in World War II. So, pretty bright guy. And he had what he called the Turing Test, which came out in 1951. And it said the intelligence of a computer, right, is required that a human being should be unable to distinguish the machine from another human being. So the real quote that he actually said was, a computer would deserve to be called intelligent if it could deceive a human being. And then later on, he turned it into a nicer statement and make a test. And by the way, you can take that test and see if you're intelligent. So if we put it against Turing's tests, none of these robots are intelligent. But we have made progress. So what we've done is, this is the early days of AUVs. You'd launch it, you'd stick with it, and then you pick it back up. Didn't take too long before we went to this model where we take it, launch it, ship would go do something else, and we pick it up later at a location predetermined. So I've done this work on a couple of systems. Docking, this has not been really popular yet, but it's really coming back. Particularly military developments are going on this right now for most of the navies around the world. And then this is a really popular one today also, where we launch from the shore and it goes off and it comes back to the shore. So we're seeing a lot of this kind of thing happen, particularly with things like wave gliders and some other robots, which are shown in the front. So here's some pros and cons to them. But again, still none of this is really intelligent. So, oh, by the way, I want to point something out. Because we're actually including surface vehicles and profilers and all kinds of stuff now, this is another term that you're going to start seeing a lot more of, autonomous marine vehicles. So even the aircraft will be included in this nowadays because they're an integrated team. So the competitions that we're sponsoring out of OES are going to start changing to this moniker. So anyway, so what qualifies as artificial intelligence, right? So when the machine can fool me or be self-aware. So now, have we ever done a computer that informs a human only if asked? A computer that informs a human only if the computer decides to? Or a computer that decides everything, acts autonomously, and can ignore the human? Anybody know what this is? I can tell you we've done it. You want to see it? Teenagers. So it's a biological computer, right? But it's self-aware, and you've probably all done this to your own parents. Ignored them when you were told to take trash out, right? Maybe told them a lie. Or when they talk to you, you haven't answered because boys are really good at this. They just ignore it. Girls are hard to you. But, so this is a fully independent, intelligent machine, right? And we purposely create them. So, okay, sometimes we argue about your college and so forth, and your parents are no longer on you about everything, right? At some point, they want you to move out and get your own job, be self-sufficient. So what are the traits of a human being, right? And you can argue what all these are and so forth, but these are some things that I think kind of define things that we are. We're creative, we have judgments, perspective, curiosity, and so forth. And then there are people who, in the world right now, who've tried to make robots have these attributes and so forth. So one action, and I'm sorry about this, okay, he's not here. Oh, there's the back. Microsoft made a robot called Tay, an AI robot, and it was supposed to be a service robot on the line. So when you called up, you'd call it and talk to it, or write to it via text. And she was supposed to learn, and then come back with answers for you and so forth. But the idea was she started off sort of blank, just like a baby, and would learn from the internet. In 24 hours, Tay became a racist and a nymphomaniac. She would spout things back that Hitler was not a bad person, and come over to my house, I want to have fun. So Microsoft took her offline in 24 hours. How did that happen? Remember the first part when I was joking about evil people doing evil things with robots? So I think people were having fun. They were making comments and so forth. But Tay actually learned those comments as a robot and brought them in and used them to grow responses. The responses in today's world are considered inappropriate, but the robot truly learned from its inputs from you, the public. So, and probably college students and teenagers who caused that problem, by the way, thinking it was funny. So, and what other ones do we have? There's Alexa and so forth, right? I have one in my house, works great. But Alexa is learning all the time. Do you know that? Right, so this is the beginnings of true AI. And she'll tell me when she can't answer a question for me, but she's getting pretty good. Knows my preferences in music, that kind of thing. So, there's another one going on right now too that you should look up if you guys are interested, because this is coming to you as roboticists, right? My generation, I'm pretty old, I probably won't see this, but it's going to come very fast. It's amazing. We got to make some decisions about it, because right now, Google just launched a thing called Perspective. Do you know about this one? Perspective is actually going through and reading all of the postings online when you have commentary about politics or whatever, something that's going on in the news. And Perspective is pulling out the ones that they consider offensive. It's starting to edit. Now, right now, it just identifies them for somebody else to go in and edit it. But the plan is to have Perspective change your wording and clean it up. So when you have an opinion on a political item, Perspective is going to say, I don't like that. That's not polite. I'll change that. So we're putting this into robots. And what happens when that robot is in your control, or supposed to be, is doing work for you, and it decides, I don't like what you're doing. So now, if you have full autonomy, you have to be prepared for the unexpected, right? So some things are good. Oh, that's right. Ice cream's good, and so forth, and having fun. Some things are bad, right? Then there's habits that also come out of this, right? So robots will begin to form habits. It'll have opinions and come back and form new ideas based on other things that it's morphed around. So can a robot lie to you? That's a question. So I've got a robot going out doing science for me, and it thinks it wants me to be happy or something like this, right? So it says, yeah, I found the answer, here it is, but maybe it's not quite right. So here's another thing. Oh, darn, it didn't show up. Well, you can kind of see it. Okay, predicted ability versus real ability. And this was done by some engineers and sociologists years ago. And it said that this is where robots will get to, right? And then this was left to the human, right? This is things that you could never get a robot to do. This was done back in the 70s, I guess it was. But if you look here, and you can see where my gray doesn't show up so well, I've actually got it up into predicting, right? Monitoring, communicating, analyzing, and exploring. I probably should back all the way over. We now have computers and robots that are actually doing predictive work, right? There's a thing called DART, out of the DARPA, and DART actually reschedules all the shipping and planning and logistics for military supplies. And DART, by doing predictive analysis and communicating and monitoring of things, paid for its entire development costs in 4 years. So it saved that much money, which was hundreds of millions, in shipping costs by doing this. So AI is here, and it's working. It's just not quite out there enough. This is another one that I thought was pretty interesting too. This is bina, and then they made this other bina. This is not a real name, by the way. I don't know what a real name is. So bina is breakthrough intelligence via neural architectures. So they took her, made a robot of her, a computer, and they had her answer tons and tons and tons of questions so that her thought processes were coded into this robot. So they made it look like her, and it talks and so forth, right, to make it like a real person. This is becoming a real trend, by the way. I don't think we're going to make torpedoes look like people, but we might have people on boats looking like people so that you communicate with them as robots. But anyway, this is what they did here. And this is what's really interesting. They asked this computer a new question, right? Could a robot get a PhD? And this was the answer. A robot with a PhD, wouldn't that be a dangerous thing? So it formed a new statement out of the programming of the other woman. It formed a conclusion. The thing that's really interesting about this is foresight. So in this idea of cognition, right? This is a robot having foresight about a question. It's like I took all these opinions and so forth that were programmed into me, and I think a robot with a PhD might be dangerous. Watson, by the way, you guys are all familiar with Watson at IBM, right? Pretty close to a PhD, I would think. I think I heard the other day that Watson now contains all of the cancer research information on the planet. Everything's been published and is now doing predictive analysis in medicine. So now, these are some things, just for you to look at when you get the slides. But if you look, and you look at these things here, predictive modeling, rules, optimization, we have natural language, Alexa, right? Learning and reasoning is just about the only thing left. If you talk about what we do in this thing of cognition, right? How to make a decision and make a good decision. So I thought this was pretty interesting. So now, I'm almost done, by the way, so you get to lunch. But if we restrict AI, right, is it actually intelligent? So if we hold it back, we don't allow the robot to form true reasoned decisions, right? Is that really just fancy programming? Right? If it doesn't become self-aware and can make decisions on its own, there's this fuzzy area that I'm still thinking about. And so Isaac Asimov, you guys are all engineers, you must know him, right? Very famous for iRobot and all the other things. He wrote these laws many, many years ago. And it's, a robot can't harm a human, it must obey the orders of a human, and it has to protect itself. The military right now, in almost every country that's fairly major with a military budget, is breaking all three of those. Right? They're developing tools and systems right now, robots to go to war. Sometimes they follow orders, I guess, but other than that, they are harming humans, and they are blowing themselves up sometimes. I think it was in the newspapers around the world. The U.S. Navy was actually just halted from building full-up autonomous submarines. So the American people were stopped from that. And so, I would say, if we look at what we've created and where we're at today, right, we only have a couple things left to do. We're getting a lot closer than I thought we'd be when I started looking into this. All of this other stuff, computers are doing just fine. I mean, Alexa tells me what I want when I ask, right? So, in conclusion, by the way, did you guys see the slide? I went past it pretty quick, where there's serious thinkers out there that are worried about this. So Elon Musk, Stephen Hawking, who's not a dumb man, Bill Gates, they want to put a stop to this. They want to have laws that hold back AI because they think it can go awry. So anyway, there's some kind of new rules coming, right, for a robot-human society. By the way, you guys are all young. I was hoping that, do you guys know what this is? That's HAL, right? Yeah. So 2001: A Space Odyssey still being seen. So if you haven't seen that, it's a good robot movie about smart robots. But anyway, so my point is, this technology is coming, and it's coming fast, and we will adopt it and put it in our robots and begin doing a lot of things in the ocean with it, especially with the multi-swarm type robot systems and that. I'm an advisor to 2 companies on fishing practices. So we're going to start sorting fish to be sustainable and so forth, and that will be all roboticized. So we'll only take tuna of a certain size. We'll only take certain fish of a certain age and whatnot. So because it's not like rockfish take back 35 years to mature before they can mate and things like that. So things we didn't know before. We think a fish, like every year it's able to have babies and stuff. It's not. So anyway, I just thought I'd put that out there as something fun for you to think about, because the young people are going to be seeing this come along. I think it's exciting, but it's got some real questions to it.